Welcome, students. Today, we're turning this digital notebook into an absolute masterclass on one of the most satisfying topics in geometry, parallelism. Whether you're seeing this for the very first time or you just need a quick refresher, we're going to build your understanding completely from the ground up. I'll be your guide as we draw, calculate, and prove our way through these angles together. Let's dive right in.
So, let's kick things off with a big question. You know those wildly complex diagrams you always see in geometry? How exactly do we find a missing angle using pure logic without ever touching a protractor? Well, I've got a really cool trick to show you. And honestly, the whole secret just comes down to understanding how straight lines interact when they cross paths.
Here's our game plan for today's explainer. First, we'll meet the transversal, then explore parallel lines and their angles. After that, we'll look at how to actually prove lines are parallel, tackle some step-by-step geometric proofs, and finally, end with a pause and practice challenge. All right, let's jump straight into section 1. Meet the transversal.
Okay, so when a straight line, which we call a transversal, intersects two or more other straight lines, it creates some very specific pairs of angles. We're going to start with corresponding angles. Notice how angle 1 and angle 8 are positioned. You've got one exterior angle and one interior angle, and they're both sitting on the exact same side of that diagonal transversal line. Basically, they perfectly correspond to each other's position at their respective intersections.
Now here's where it gets really interesting. There's actually a hidden letter hiding right in plain sight. If you trace the path from angle 3, right along the transversal and down to angle 8, you get a Z shape. These are our alternating interior angles. They're tucked inside the two horizontal lines, but on opposite sides of our transversal. Trust me, finding that Z is a fantastic visual shortcut you're going to use all the time.
Finally, we have interior angles on the same side of the transversal. Take a look at angles 3 and 5. If you trace the lines around them, they form this distinct U or C shape, perfectly tucked inside the two intersected lines. Honestly, getting comfortable with these specific relationships, corresponding, alternating, and same side is totally crucial. It's literally the key to unlocking the rest of this lesson.
Moving right along to section 2, parallel lines and angles. So the really crucial thing to know is that when those two lines are perfectly parallel, meaning they will never ever touch, these 4 golden rules instantly come into play. Your corresponding angles, perfectly equal. Your alternating interior angles, that Z shape, also equal. Alternating exterior angles, equal too. But wait, look at that last rule. Same side interior angles are actually not equal, they are supplementary. And that means they add up to exactly 180 degrees.
Actually, let's pause for a second because I really want to highlight this. This is a super common exam trap. You have to be so careful here. Many students make a huge mistake by thinking supplementary means 90 degrees, or they accidentally assume same side interior angles are just equal like the others. Remember that U shape we talked about? They stack together to make a flat line's worth of degrees, which is strictly 180. No exceptions.
Let's test this out with a real example right here on our notebook. Say we're given that line AB is parallel to line CD. A transversal cuts through them, and we know our first interior angle, angle X, is exactly 70 degrees. What I want you to do is find the measure of its alternating interior angle, which we'll call Y, and the interior angle on the same side, which we'll call Z. Go ahead and pause this explainer right now, grab a pencil, and try to write out the steps yourself before I show you the solution.
Okay, let's walk through the solution step by step together. Since the lines are parallel, our first rule totally applies. Alternating interior angles are equal. Boom. That means angle Y is exactly 70 degrees. Simple as that. Now, for step 2, we know same side interior angles are supplementary. So for step 3, to find angle Z, we literally just write out 180 degrees minus our 70 degrees, which gives us a final answer of 110 degrees for angle Z. See? Writing it out step by step like this completely prevents those silly little subtraction errors.
All right, section 3, proving lines are parallel.
Let's look at line MN and line PQ, which are both intersected by transversal XY. We're given two angles here, 127 degrees at the top intersection and 53 degrees down at the bottom. The question is, are lines MN and PQ parallel? Well, we can't just guess by eyeballing it, right? We have to mathematically prove it.
To successfully prove that two straight lines are parallel, you actually only need to show that just one of our golden conditions is met, kind of in reverse. If you can find two corresponding angles that just happen to be exactly equal, then the lines absolutely must be parallel. If you find the alternating z-angles are equal, parallel. Or if you find two same-side interior angles that perfectly add up to 180 degrees, boom, they're parallel. It's like a geometry cheat code.
Now for Section 4, Step-by-Step Geometric Proofs.
Check out this jagged shape here. Honestly, this is a classic, super common exam question. We're given that the top line AB is parallel to the bottom line CD, and we have this point E just sort of floating right in the middle. We know the top angle BAE is 40 degrees, and the bottom angle DCE is 30 degrees. What we need to do is find the measure of that middle angle, AEC. But here's the catch. There's no single straight transversal line connecting AB and CD directly to let us use our rules. So what do?
Well, this brilliantly illustrates where geometry basically becomes an art form. When you're stuck, you construct a solution. Our construction step here is to literally draw a brand new auxiliary ray. Watch as we sketch EF passing horizontally straight through point E in the middle, making it perfectly parallel to the top line AB. And here is the absolute magic of this trick. If it's parallel to the top line, it is automatically parallel to the bottom line CD as well. Just like that, we now have two distinct transversals to work with.
Now, watch how this formal proof builds line by line. First, since AB is parallel to our new line EF, we can look at the top Z shape. The measure of angle AEF has to equal the 40 degrees of angle BAE because, you guess it, they're alternating interior angles. We'll write that down. Second step, looking at the bottom half. Since CD is parallel to EF, the bottom Z shape tells us angle CEF equals the 30 degrees of angle DCE. Same exact reason. Finally, to find the entire middle angle AEC, we just add our two pieces together. 40 degrees plus 30 degrees gives us a final answer of exactly 70 degrees, step-by-step logic flawlessly executed.
And that brings us to Section 5, our Pause and Practice Challenge. All right, here is your homework challenge straight from our digital notebook. We've got a trapezium ABCD. We are given that the top base AB is completely parallel to the bottom base CD, and we have a diagonal line BD cutting right through it. We also know that angle BAD at the top left is 100 degrees, and angle ABD is 46 degrees. I want you to analyze this shape really carefully. Keep our parallel rules, our Z shapes, and your basic triangle rules fresh in your mind.
So the ultimate question is, can you find the missing angle ADB? You absolutely have all the tools you need to solve this, from knowing how alternating interior angles work to remembering that the angles inside any triangle always add up to 180 degrees. Write out your steps exactly like we just practiced, and once you solve it, ask yourself this: how many other hidden transversals and parallel lines are shaping the architecture and structures in the world around you right now? Geometry is literally everywhere. Keep visualizing, keep practicing, and I'll see you in the next explainer.